Hello, Dr. Shim. This is our semester 1 project. We're doing problem number 4, and our group members is Elliott Hong, James Kim, and Ryan Shim. Problem number 4, bouncing spring. A weight attached to the end of a long spring is bouncing up and down, as you can see in the figure below. As it bounces, its distance from the floor varies sinusoidally with time. We start a stopwatch when the stopwatch reads 0.3 seconds. The weight first reaches a point 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. The two questions we ask here is A. Sketch a graph of the sinusoidal function and write an equation expressing distance from the floor in terms of seconds the stopwatch reads, using a cosine function, and that will be done by James Kim. And B. Predict the distance from the floor when the stopwatch reads 17.2 seconds, and that will be done by Ryan.
According to the problem number 4, it mentions that when the stopwatch reads 0.3 seconds, the weight would reach 60 centimeter, and when the stopwatch reaches 1.8 seconds, the weight could reach 40 seconds periodically, so it keeps returning back to 60, 40, 60, 40, something like that. So since we got to use cosine function, we use this formula, y equals a cosine bx plus c plus d. So since period is like a 3 because it keep going like 0.3 to 3.3 periodically, we can also determine b using formula 2 pi over absolute value of b equals 3. So we can know that b equals 2 pi over 3. And we can know that the weight is moving around 40 to 60. The amplitude should be 10. And also, since the range of the weight is 40 to 60 and the middle number is 50, the d, which is vertical shift, could be 50.
So for problem B, according to the graph equation, since x represents the time, insert 17.2 in x on calculator. So the result is about 43.31.
Thank you for watching.